Okay, so div 1 round today. I hope I can solve A and B maybe. That would be good considering my previous div 1 rounds. Okay, so I don't know. Okay, so I don't know how to solve this. Okay, but if we have a m by n grid, we know that there will be m times n plus 1 horizontal pieces and n times m plus 1 vertical. So we need to have p plus 2 times q equals to 2mn plus m plus n. Okay. So I'm guessing that okay, so we have this expression here, so we can probably multiply this by maybe probably 2. So we get 2p times 4 plus 4q equals 4mn plus 2m plus 2n, and then we add 1 to both sides, so we have 2p plus 4q plus 1 equals, this is 2m plus 1 times 2n plus 1. Okay, so now okay, right, so this will be, so 2p plus 4q is about 10 to the 8, right? So I guess I can put maybe like 7. I think that this should run in 1 second maybe, right? And then we have like right, and okay, so yeah, of course we want this, we want to factor this, and probably have m and n be as close as possible. Okay, yeah, so I think that this is too slow for one, and yeah, and I mean, I would assume that if we find like m and n as close as possible, and q is less than or equal to the minimum of horizontal and vertical pieces, then this is possible, probably. But I have no idea how to do that. okay. So yeah, I guess I can do something like this maybe, because the number of test cases is low. I can probably just like do root of this number. Yeah, okay. Yeah, and yeah, we want 2 because if the number is like 1, actually this isn't answer, this is like n, and then there is an additional check, right? But if it's like this, then n equals I, and m equals I, right? Okay. And now -1, -1. Yeah, and we don't want 1 here because that would mean that one of these is equal to 1, which would mean that either m or n are 1, 0, which is, well, impossible. So now we find like the closest pair, and then to the closest pair such that their product is this, and then probably the smaller of these two numbers would be, I think, n plus 1 times n. And if not, then the answer is impossible, I think. Now, let's check samples. Oh, okay. -1. That's okay. I think that's this is almost correct. I think, yeah, I mean, we found 2n plus 1 and 2n plus 1, so probably just need to divide this by 2 and this by 2, and they're both odd, so the rounding will take care of the -1. So now, if we test samples, this should be correct. Yeah, this one. Yeah, this seems okay. Okay, 15 minutes. I mean, I guess it's fine if it's correct. I mean, complexity is about t times root p plus q, which is like in total about maybe 10 to the 6th operations, which should pass the time limit. Wow, Q forces. Amazing. Oh. Yeah, I guess everyone is stuck in Q, probably. Alright then, B. Okay. Hmm. Okay, then. Okay, so what I think you can do here is probably, I mean binary search of course, but because every value except one appears exactly 2 times, that means that if that value is not repeated 3 times, the parity of the length is equal to the number of elements that appear exactly once, right? Meaning, yeah, like okay, yeah. Okay. So yeah, we can like binary search from both the left side to find the last index and from the right side to find the first index of the 3 repeating elements, and then combine them to yeah, and then you have like an array in the middle. You can then binary search where the last value is in that one. Yo. Okay, wrong answer too, that's bad. Okay. Yeah, I missed it here. I messed it up. yeah, so you need okay, yeah, okay, fine, I see the problem. Okay, so I think that should be A actually. I'm using a Q, but yeah, I guess I suppose that this is idea for B. Yeah, so you need about log n operations to find one index, log n to find the second one, and log n to find the third. So okay. Yeah, so that's in total about 3 log n, because n is 1000, log n is about, let's say, 11, so this should comfortably pass both b1 and b2. Maybe, if I implement this correctly. Alright, I need this. Question mark. Mid. Okay. And this, because this is interactive, I don't want that one. Yeah, so then we have number that we have to read. Then we check if this is even or odd. If this is even, that means that actually, yeah, like this. Okay. I think this should be okay. Yeah, then left index, actually no, this one would be right index, because this is the last one, right? Okay, then probably just do the same for the second one, yeah. Except, of course, we want like this, I think. Yeah, and then this would be 2 times n plus 1 minus mid, yeah. I think, maybe. Plus 2, maybe. I think so, yeah. like if mid is equal to 2n plus 1, yeah, okay, never mind. Yeah, this is 0 indexed, so this needs to be like this, yeah. Then again, here probably less than or equal to. Mid plus 1, maybe. I think something like this. Yeah, okay. Okay. Yeah, but this will be left index. I think this works out. No. Oops. Oh. That might be bad. I think this is less than or equal to, and wait, no. Actually, maybe. No, I don't think this works. I think this just has to be like n times n. I don't know, like in this case here. No, rather in this case here. Like you have 1, 2, 3, 4, 5, 6 of these. Actually, yeah, okay. Yeah, this construction probably works in general. Actually, probably. Yeah. Probably, yeah. Okay, let me check this case. So like p is equal to 0, and then you have 1, 2, 3, 4, 5, 6. Okay. What if you have like 2 more? So that would mean 8 in total plus 1, no, this normal one. Okay, I think. Okay, wait. So if I make like 2 times 4, I think the best you can do is like 2 horizontal ones and then 10 L ones. Okay, but if I increase that to 0 horizontal ones and 11 L ones, that shouldn't work, right? Okay. Oh, okay, yeah, I guess this one is smaller. Yeah, sure. Yeah, and I think you need to have less than or equal to. Yeah, sure, okay. Yeah, surely this works. Maybe. We'll see. But yeah, back to implementing B. Yeah, I want to check this. If this correctly finds the indices. I suppose I'll take an array like 1, 2, 1, 2, 1. Okay. That's 2. Okay, 1, 2, 3. So there's one unique number here, right? Okay, 1, 2, 3 again. 1. Okay. I'm stupid. Sorry. And parity might be wrong here. We'll see. Again, this one. Yeah, so 1. Okay. Yeah, this. Okay, so first of all, I forgot to reset these numbers. That's the first thing that is obviously incorrect. And then I think that this parity is wrong here. Yeah, maybe. Actually, I'd rather have not equal to. Okay. There's 0 here. And then, okay, so in this one there's 1. And in, okay, yeah, this parity is wrong, I think. Okay, so there's 1 here. Wait, which? Sorry. I think that this might work. Okay, first, let's see this. Q again. That's fine, I guess. Okay, 1, 0, Okay, then here there's 1, here there are 0. Okay, in the whole array there is 0 again. Okay, so I think it gets strongly. Yeah, I don't know. I think for this case it should be like this maybe. And it should be like this. Okay. 1, 0. Here there's 1, and here there is 0. Yeah, okay, 0, 4. That's okay because for me it's like 0 indexed, so 0 is actually, yeah, okay, it found 2 correctly. So now I think I just copy this, but I put L as left index and R as right index. Yeah. Okay. Okay. Yeah, this is fine. This is okay. Now the only difference here is that this will be like distance from mid to L, or rather left index +1, because I want to like print the right index too. And the same thing goes here. Okay, here it's 1, 0, here it's again 1, 0. Now for this one, 1, 2, 3, 4. Okay, first I missed number of elements. I think it should be this +1. Rather, yeah. 1, 2, 3, 4. Yeah, okay. I need a right index +1. Okay. Yeah, that is 1, right? Okay, so yeah, I think that should do the trick. Yeah, maybe. Okay, pretest passed, amazing. But here, I mean, 2 wrong answers is kinda bad, honestly. 100 penalty, that's I mean, it's fine. Okay, so now 1, 2, 3, 5. There is 1 here. Yeah, 1, 2, 5. There is again 1 here. Yeah, okay. Okay, so I'll add this, but if it's like output 0, 2, 4, and that's the solution probably. Okay, that's it. That's B. Yeah. Also means to both B, B1 and B2. Because like the complexity should be fine. I mean, Q is kind of like cringe, not gonna lie. Like 10-minute Q. What can we do about it? Okay. I mean, okay, wrong answer on pretest 1. That's kind of unfortunate. Not gonna lie. But better that than wrong answer on pretest 2. Am I right? Okay, I'll check this one. Okay. Okay. 1, 2, 3. There is 0. 1, 2, 0 again. One, 0. Okay. And then 1, 2, 3. There is again 0. 1, 3. 0. Yeah, 1, 2, 3. Oh yeah. I forgot. I mean, oops. Now for this one, I would expect like you would probably do this greedily. Yeah, like select the node A that has the largest ratio of, select the black node A that has largest ratio of red to black node, red to total neighbors, and then like select it until it becomes red. And we know that in no, wrong answer on pretest 2. Man. I don't feel like doing this. Not gonna lie. I mean B is kinda yeah, anyway, like if a probability of event happening is like P, then the expected value of times you need to do it until you get at least one good outcome is 1 over P. Yeah. So like, I don't know. Okay. I mean, okay. I think the problem is here. Yeah. Like, depending on L1 run, or yeah, depending on left index, this mid, like, yeah, I mean, like 100% this is the problem. So yeah, probably this. Yeah. Now, just need to check like what's the parity of, if this is 1, 2, 3, 5. There is a 1 here. One, 2, 5. There's one here as well. And 1, 2, 1, 3, 5. Okay. Yeah. I think this should pass pretests now. And not gonna lie, I'm gonna wait to see if this passes B1 until I submit this to B2, because I don't want to get wrong answer on pretest 2 for no reason on B2, yeah. Anyway, I suppose here, okay, pretest pass here, amazing, that's good. I'll submit here too, because I think that the number of operations is okay. Also, I'm curious, okay, this is this A1B, A2, div1, div1A, div2C, that's fine. Okay. Now, okay, pass pretests, that's good. This is, yeah. Now here, string s. Okay. Yeah. Okay. Yeah. And I mean, no, actually, no, I messed up. There's no, oops. Yeah, no need for any vector. Here, there's UV, scene, UV. Yeah, because I like to be zero indexed, yeah. Now 3 U pushback V 3 V pushback U. Okay, now I would assume that the difficulty is like finding the next node that you need to color red, but yeah, I think you can do something like this, like priority Q, pair in long double int, yeah, because the first one will be the ratio of the red nodes divided by total neighbors, red neighbors divided by total neighbors. The second will be the node number, yeah. Okay. Long double answer. Okay. Now if the current one is, I think, red, then we continue. Okay. Now if it's black, actually. Okay. Okay, now if actually I don't like priority queue, I'll take set instead. And in addition, so I can yeah, like I'll keep count of how many adjacent neighbors of n are red. It doesn't matter that much for nodes that are already red, but for nodes that aren't, it does, so that I don't need to look it up every time. Yeah, so like this. Okay, and now if this one is black, red plus plus. Okay. Now okay, now I always forget which like is are sets sorted. Yeah, actually they're sorted in increasing order, so I probably need to look at like the last element. Actually I forgot to add anything to the queue. Queue dot insert. Now this one will be minus red divided by total. Yeah, and I put long double here so it can be like normal division, like the one that I need, not integer division. And this so that the largest one is on the front. Okay, and then or the largest one is on the beginning. And then the second one will obviously be I. Okay, now just want to check this. I'll check this first sample. Interesting. Yeah, okay. Oops. Sorry. Yeah, I mean, interesting. But okay, minus actually this is probably a bad example because it has all ones or only one element actually. So probably something like this is yeah, okay, so the largest one is on the front. which is what I wanted. Yeah, so okay. Okay, and now I think yeah, like every edge will be used at most once to update something. So for that reason, I think that the complexity is okay. Okay, and now I just need to update everything, right? So again, something like this. 3 of p dot second. Yeah. Now if they are red, I guess continue. If they are black, I will probably okay. Yeah, like this, and then I'll find the position of like this. Then I will erase it, and then insert basically the same thing, except I'll just oops. Yeah, and this, yeah. This should work, I suppose. Maybe. We'll see. Yeah. I have no idea, man. New allocator. Oh, okay. Yeah, this probably like doesn't exist. Ah, okay. Yeah, I know. I understand now. Yeah, I just need to like put s of p dot second is equal to 1 here, and that should solve the problem. Yeah. Okay. And this is 1, 4.5, 2. Again, interesting. Again, this is which test case? Probably the second one. Yeah, I'd suppose. Yeah, n equals 5. That's the second one. Okay, let me see. Okay, so red. So these are red, these are black. Yeah, and it messes itself up at what point? Oh yeah, S 0, 1, 0, 0, 1, 0. Yeah. Okay, maybe this. Yeah, I forgot the minus. Oops. Yeah, this might work. Okay. No. Yeah, I have no idea. Q erase. Interesting that it didn't return an error. That's unfortunate. Yeah. I mean, I have no idea what to do. Also, I like focus just on the second sample because the other, I mean, this is the buggy one. Yeah. Okay, this actually works, surprisingly, or unsurprisingly, I don't know. Yeah, I mean, I guess stop this one, then this one, then this one, guaranteed. Yeah, okay. Then wait, okay, yeah, okay. Yeah, it's best to first do this one, then this one, then this one. Okay, I thought it's best to first do two and then the other ones. No, yeah, okay. All right, that probably means that it probably means I forgot to clear this. Yeah. 1, 4.5, 2. Okay, now just delete this one, and this should be fine. I mean, this passes samples, right? Which means I don't know. It should mean something. I mean, the logic should be correct. Okay. Wrong answer on pretest 5. Amazing. This is okay. Yeah, maybe this isn't greedy. Okay, actually, I think it is, but I think the problem arises when two numbers are tied. Like, what should be the tiebreaker? I think the priority should go to the one with maybe more neighbors. Like, I think this matters, maybe. Yeah. Okay. Okay. Yeah, and then, I mean, honestly, I would assume that you either prioritize guys with more neighbors or guys with less neighbors. Or rather knows, yeah. And I would assume, with no proof, that you prioritize more neighbors, and that's the case. I think that this might work. I mean, if this passes these samples, yeah, that means there's no bug in implementation, which means it might pass. Yeah, I mean, like, if you got two nodes that both got like a 1/3, but one actually has like, okay, again, wrong answer. Maybe okay. Okay, I don't know, honestly. It might not even be greedy. It might be something else. Actually, it probably is something else. Honestly, I'm quite surprised that greedy seems this good when it isn't the solution. Yeah, now dp of I would be like the answer to the like, actually I think it should be like pair. Yeah. Because like I wanna put the first one, if like would be the answer if for that subtree if the node is black and if the node is red. don't know. Well, I have no idea, actually. Yeah. Okay. So let's say that these are two nodes. Then there's another one here. And then maybe like all three of these are like black. So you want to color them red, yeah. But then you also have like this one has two red neighbors. Okay, so the ratio of this one would be 2/3, and then this one has maybe 4. Okay, and the ratio of this one is again 2/3. Now the question would be, which of these do I want to do first? Like if I do this one first, then this becomes 1 and this becomes 1. But if I do this one first, this becomes 5/6. And after I do this, this becomes 1. Meaning, yeah, it seems like this one is better. But, yeah, so, oops. That means, yeah, because that's the code I submitted, like, it first prioritizes the ratio and then the number of neighbors. That would mean that this isn't the solution, and then it's probably some like DP. Meaning, not gonna lie, I have no idea. Like, maybe some of these are colored, some of these aren't. Maybe this one is. Yeah, okay, the rest of these are black. Something like this maybe. Now, how do I calculate this? Well, okay, so yeah, okay, yeah, the dpfi is the solution to node I, or the subtree of node I. If let's say 0 is the root, then yeah, and it has two values. First one would be if I leave it the color that it is, and the second one is if I force it to be red. Now, how would I calculate that? Okay, so I have no idea. I mean, okay, for the root it's simple probably. If you leave it as it is, that's just a actually no, even that isn't simple. I have no idea then, man. I should be able to solve this, honestly, but I don't know. Okay, let's see for this example. I think the solution would be Well, to first do this one, because that one doesn't change, that adds 1. Then to do this one, which adds 2. Yeah, exactly half its neighbors are red. And then this one adds 1, and this one adds 1, so in total it's 5. Okay. Yeah, okay. I mean, I'm almost certain the solution is something like dynamic programming of node is the solution to like its subtree, and then maybe I need 2 dynamic programmings. Like one would be the solution if I only go like from up to down, from down to up, and then another would be like everything except this subtree. But like for this node, it would be its whole subtree excluding the node itself. But that would be tricky to calculate. Oh, okay, wait. Maybe I just need to solve like the problem. Should I color nodes? Like this reminds me of exchange argument. Like, should I color this node before this one? Yeah, and if I can solve that, but that's tricky to solve, honestly. I mean, if I were to look at this that way, that would prioritize nodes with less neighbors, and that's obvious. Or no, yeah, but the problem is that depends on literally what was before, and right, yeah, like if I colored something here, and then I have some node D and J, and then I have something left, like depending on this, it would be better to swap them. I mean, if they aren't adjacent, it doesn't matter, and if they are, you'd probably prioritize the one with the higher higher like ratio, or no, actually it wouldn't be that. It would be if ratio of E of I plus the ratio of J that is adjusted by 1 is less than or equal to the ratio of J plus the ratio of I adjusted by 1. Yeah, that's what it is. Now the problem is it depends on this, and it depends on this, and I don't think the constraints are, yeah, if it was like n is 10 to the third, then I could like bubble sort this, so I know exactly what's before and what's after. But I can't here, right? And that's bad, right? Yeah, I mean, obviously, if they aren't adjacent, this doesn't, like, they don't affect each other, and if they are, you should, like, like, oops, red neighbors of I, all divided by total for I plus red of J plus 1 divided by total, but this simplifies to yeah, and on both sides you have, like, here you'll have this, yeah, like, this doesn't make sense to me, because this simplifies, and then you just get that it's better if to, like, greedily take the one with oh, actually, no, I messed it up. No, it isn't this, it's 1 over this. Yeah, okay. No, yeah, and that's much harder, because you, like, the numerator, oh, okay, stays the same, but the denominator changes. Oh, but wait, you might be able to do something with that. Hold up. Okay, I'll probably do something like this, then scale, then paste this again. Okay, yeah, okay. Total of J. Yeah, no, this is incorrect. no, it's like the opposite. Total of I divided by red of I plus total of J divided by red of J plus 1. Yeah, and like depending on which one is smaller, you're gonna like I think that if this is greater than or equal to the same thing, but like with red I plus red of I plus 1, like total of I divided by red I plus 1, then you should swap them, and meaning that if I take this one to this side and this one to that side, you get total of I divided by red I times red of I plus 1, where this is like the number of red nodes at that moment, and then if this is greater than or equal to the number of like this one, you should take it, I think. Well, okay. Yeah, and I want to take the smallest one at any point, maybe. No, actually, this means if this is smaller, that means that this is smaller. That means that I should go before J. Okay, so yeah, if this is 0, I'll just set this to be like infinity, and in any other case I'll just sort by this value, and I'll take the lowest one at this point, and then update everything accordingly, and then repeat. Yeah, that's like this. I mean, if this is the solution, that would be amazing, but I'm not confident, honestly. I mean, it would be cool, but again, I'm not sure. Okay, in that case, I will make, yeah, this adjacent is basically like the red at current point vector. So I would want to put this value to be, okay, I'll go back to just long double, not pair long double int. Like, it's obvious that that's not the solution, and Okay. And there will always be some number like less than infinity. I'll put it to be like something huge. Okay, actually, wait, there is infinity, maybe plus infinity. Huge val. Actually, yeah, I'll just put some number like 10 to the 50. I think that should fit in a long double, and that's maybe a bit larger. Yeah, this still fits in. I mean, this is fine, probably. This is large enough that it should be larger than any normal value, and still be like infinity. Yeah, okay. Okay, so if the adjacent number is 0, then we'll put that number is equal to infinity, and else I'll put number equal to total divided by red times red plus 1. Okay, and probably do the same here. I mean, oh yeah, long double. What's the problem here? I don't understand. Yeah, what's the problem? Amazing. Anyway, yeah, the same goes here. If adjacent of x on double, if adjacent of x is equal to 0, the number is infinity, and in the other case it will be the number of its neighbors, x, divided by, well, the number of adjacent elements of x times the number of adjacent elements of x plus 1, yeah, and then I'll copy this here. Yeah, okay. Okay, and then same thing. Yeah, okay, now let's see, does this throw a problem? Yeah, amazing. Conversion from long double. What? No, and also here, yeah, you need this, but oh yeah, I forgot. Oh yeah, okay, I forgot to change the type of P. Oops. And yeah, here it doesn't have to be 1 over, but just P dot first. Now okay. Wait, what? Okay, erase. I mean, I'm guessing it can't find this element, which is a bit problematic, considering I have 6 minutes left and not enough time to debug. Invalid pointer, yeah. I'm guessing that's what's going on. And this is showing a problem on the first iteration. Oh yeah, okay, I understand. Yeah, this this is okay. Yeah, this should do the trick, maybe. Or no, rather, wait. Yeah, I forgot. Now I don't want the largest element, I want the smallest one. So yeah, this infinity should stay like infinity, but whenever I'm finding or adding something, it should be like not negative, because I don't want largest numbers anymore, I want smallest ones. Okay. Now, yeah. Again, invalid pointer, what? -1, what? -1, 2. What? I don't know, maybe I made this number too large. I'll put something smaller. Actually, something like 40 maybe. I mean, I have no idea what I'm doing wrong. Honestly. But something isn't working out, obviously, and Okay, so yeah. Yeah, so it says that this one that its answer is like okay. I'll just put one. Okay, this one invalid pointer. Okay, I'm not solving this. 2 minutes left. Unless I, by some miracle, find the bug immediately. I ain't solving this. I mean, two. Okay, I first of all shouldn't be multiplying by -1 here, but that obviously isn't the only problem I have. Oh yeah, and this isn't the value that I should be adding to the answer. It should be like 3 of p dot second divided by g since c at p dot second. Yeah, dot size. That also doesn't work, I think. Oh yeah. I don't know. I'll submit just in case, but like, yeah, this doesn't work. I mean, I feel like I got the right idea, but I don't know. I was too slow again. Another round, another bad performance, I guess. I mean, this isn't the end of the world. Like, I did fine, but I feel like I could have solved this D or C rather. But I mean, I'm satisfied with how I did. Probably. I mean, I have no idea like what performance I got or what data I'll get, but judging by how many people registered and my placement, like I'm 500 out of 700, that's probably gonna be like minus maybe 50, probably. Yeah, minus 50, I'd reckon, something like that. I mean, important thing is that I don't drop out of candidate master. As long as I'm candidate master, I suppose I'd be able to get back to master relatively easily. I don't know. Anyway, yeah. Okay, that's it probably. Okay, pending system testing. I mean, this is okay. Like it's good. Yes, it could have been a bit better, but I'm satisfied with how I did this round.